This is Chapter 3, Lesson 3, Equation in y equals mx form. So, we can recall that when the ratio of two variable quantities is constant, a proportional relationship exists. This relationship is called a blank blank, and those two blanks you're going to write direct variation. Direct variation. The constant ratio is called the blank 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 or blank blank blank. So it's called the constant of variation or constant of proportionality. Okay, so let's look at some examples. So a linear relationship is a direct variation when the ratio of y to x is a constant, m, and we usually say m, okay? We say y varies directly with x. So in symbols, m equals y over x or y equals mx, where m is the constant of variation and m does not equal 0. Okay? So examples, y minus 3x or y equals 3x would be an example. Anything that is similar to that, okay? So let's take a look at a specific example. All right. So the amount of money Robin earns while babysitting varies directly with the time as shown in the graph. Determine the amount that Robin earns per hour. To determine the amount Robin earns per hour, or the unit rate, I find the constant of variation. So I can either look at the graph or I can take some of the points. There are a couple of points that I could use. I can use the points 2, 15, 3, 22.5, and 4, 30. Okay, so I take the amount earned divided by the time. So the first one I have is 15 divided by 2, which is 7.5. Then I can take 22.5 divided by 3, which gives me 7.5, and 30 divided by 4, which gives me 7.5. So Robin earns, because it's constant, Robin earns $7.50 for each hour she babysits. The other example I have is a cyclist can ride 3 miles in 0.25 hours. Assume that the distance biked in miles y varies directly with time in hours x. This situation can be represented by y equals 12x. Graph the equation. How far can the cyclist ride per hour? Okay, so first I can make a table of values. Then I can graph the equation y equals 12x. In a direct variation equation, m represents the slope, so the slope of the line is 12 over 1. Okay, so the first thing I want to look at is the table. So, table, for 0 hours, I have my equation y equals 12 times 0, which gives me 0. So in no hours, the cyclist didn't go anywhere, 0 miles. Okay. In 1 hour, the cyclist went 12 miles. And then in 2 hours, the cyclist went 24 miles. Okay. So you can see when I graph my equation, okay, so remember rise over run for slope, okay, this tells me I rise from 0 up to 12, and then I go over 1. I rise 12, I go over 1. Okay, so each time I'm going up 12 and over 1. That's what my slope told me to do. All right, so there are a couple of try it problems. I have 2 on this page. So go ahead, pause the video, try out the try it problems, and when you come back, we will go over the answers together. All right, now that you've had a chance to try the try it problems, let's go over the answers together. So letter A says 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. After 5 minutes, he descended 4,750 feet. If the distance varies directly with the time, at what rate is the skydiver moving? Okay, so the distance varies directly with the time, which means my distance is y and my time is x. Okay, so they gave me a couple of points. Distance is y, time is x, right? So they gave me a couple of points to use. 2 minutes. So at 2 minutes, he went 1,900, and at 5 minutes, he went 4,750. Okay. So what I can do now is I can take those numbers and I can divide them. So I'm going to take 1,900 divided by 2, and I'm going to take 4,750 divided by 5, and I should get the same answer. Okay, so 1,900 divided by 2 gives me 950. 4,750 divided by 5 also gives me 950. Okay, so 950 is my slope. That's the rate the skydiver is moving. He's moving 950 feet per minute. Okay. The other thing that I want to think about too is the fact that he's descending, he's going down. So this is actually going to be a negative 950. Okay. The other try it problem I have B, a grocery store sells 6 oranges for $2. Assume that the cost of the oranges varies directly with the number of oranges. This situation can be represented by y equals 1/3 x. Graph the situation. And what's the cost per orange? Okay, so the first thing I want to do is I can look at my graph, I can graph the information, and I can create a table. So let's go over here, create a table. Okay, so B by 0. Okay, so if I buy 0 oranges, my cost is $0. If I buy 1 orange, that's 1/3 times 1, which is about 33 cents. If I buy 6 oranges, okay, 6 divided by 3 would give me 2, so $2. Okay, so that's where it's coming from. So I know 1 orange costs 33 cents, about, roughly. Okay, so the X represents the number of oranges and the Y represents the cost. Represents the cost. Okay. All right. So now I'm going to go ahead and graph this. Okay. So this tells me I'm going to start at 0, 0, right? So I know that 3 oranges is going to cost $1. So if I go up to 1, I can go over to 3. There's my first point. Go up 1, over 3, up 1, over 3. Okay, so this has created a line that goes through each of those points and continues on. Okay. And that is the end of lesson 3.